You know, there's a technology that's completely changing our world, from the clothes we wear to the phones in our hands. But to really see it, you've got to think on a scale that's, well, almost impossibly small. This is the story of nanotechnology. Now, that sentence might sound a little dense, but it's the big idea that powers this entire field. It's not just about making things smaller. It's about building totally new things atom by atom with a kind of precision we've never, ever had before. It's this wild promise of having complete control over the very fabric of reality. And look, for a long, long time, that's exactly what it all sounded like. Pure science fiction. The ideas were so revolutionary, they felt like they were pulled straight from a novel set, hundreds of years in the future. So you have this guy, K. Eric Drexler, who writes a book back in 1986 called Engines of Creation. And in it, he paints this incredible picture. He talks about these tiny, self-replicating robots, nanobots, that could go into your body and fix cells or build literally anything you want from just raw materials. It was this stunning vision of a techno-utopia. But, there's always a flip side, right? This idea of self-replicating machines sparked a pretty terrifying thought. What if we lose control? What if they just don't stop? This was the gray goo scenario, where these nanobots would just keep making copies of themselves, consuming the entire planet in a mindless swarm. And as dramatic as that sounds, it really highlights the sheer power we were talking about unlocking here. Okay, so how do we get from these sci-fi fears to actual real-world science? Well, it all came down to one huge breakthrough. One that let us not just see, but for the first time actually reach out and touch the atomic world. The tool that changed everything is called the Scanning Tunneling Microscope, or STM. Now, it's not a microscope like you're picturing. It has this incredibly fine needle that it scans just fractions of an atom above a surface. I love this analogy. Think of it like a blind man tapping a cane. It feels the bumps of individual atoms by measuring a tiny electrical current. It's incredible. And this is what they could do with it. This isn't just a picture of atoms, it's a structure they built with atoms. Scientists at IBM literally used the tip of that STM to pick up and plop down 48 individual iron atoms into this perfect little circle. This was it. This was the moment the dream became real. We could officially play with the building blocks of matter. So, now we can see and touch this nano world. But the thing is, we quickly realized that down there, the rules of physics are just different. Let's try to wrap our heads around this scale, okay? We'll take a little trip. Start with something you can see, like the head of a pin. Now go smaller, into the world of human hair, of red blood cells. That's the micro world. To get to the nano world, you have to go 1,000 times smaller still. A nanometer is a billionth of a meter. It's almost impossible to picture. A single strand of your DNA, that's about 2.5 nanometers wide. And here's where things get really, really weird. When stuff gets this small, its basic properties just change. Take gold. We all know what gold looks like, right? Yellow, shiny, metallic. But if you break it down into nano-sized particles, it can suddenly appear red. Not only that, its fluorescence can be boosted by over 10 times million times. It's the same exact material, just with totally new superpowers. That's the magic trick of nano. So this completely changes how we can make things. For pretty much all of human history, we've used a top-down approach. Think of a sculptor with a big block of marble, chipping away everything that is in the statue. That's how we make computer chips. But nanotechnology gives us the bottom-up approach. You start with the tiniest pieces, atoms and molecules, and you build up. It's literally like building with Legos at the atomic level. All right, I know what you might be thinking. This all sounds very cool, but very futuristic. Here's the kicker. This bottom-up revolution, it's already started. In fact, you are probably using nanotechnology right now, and you don't even have a clue. Have you ever owned a pair of stain-resistant pants? The kind where you spill something and it just beads up and rolls right off? Yeah, that's nanotech. They figured out how to weave these tiny, nano-sized whiskers into the fabric. They're so small, they create a cushion of air that repels liquids. So if you've got those, congratulations, you're wearing nanotech. And what about sunscreen? Remember that thick, white, pasty stuff that you'd have to smear all over your face? The reason modern sunscreens rub in clear is because of nanoparticles. They use tiny particles of zinc oxide that are just as good at blocking UV rays, but because they're so small, they're invisible to our eyes. Your car? Yep, it's probably in there too. Companies like GM and Toyota are mixing nanoparticles into plastics to create what they call nanocomposites. And get this, by doing that, they can make a car bumper 60% lighter, but also make it twice as resistant to dents and scratches. Lighter and stronger. That's the holy grail.
But if you really want to see the most staggering impact, you gotta look at electronics. The very first transistor, back in 1947, was big enough to hold in your hand. Today, the smallest ones are over 1.4 million times smaller. That's not just a gradual improvement. That is a complete and total transformation.
So what that means is that right now, we are building computer parts where the placement of just a handful of atoms makes all the difference. And the smartphone in your pocket, the reason it's so powerful is because there are billions of these tiny nanoscale switches packed onto a single chip. It's amazing. Okay, so that's today, and it's already pretty incredible. But what about tomorrow? Where is all this taking us? What does the future look like when we can truly build anything we want, atom by atom? Well, the possibilities are just mind-bending. I mean, just try to imagine this. Medical nanobots that swim through your bloodstream, hunting down cancer cells one by one. Materials made from shatterproof diamond that are 50 times lighter than steel. Storage devices that could hold all the data on the entire internet in something the size of a sugar cube. And of course, the ultimate goal, molecular manufacturing, a real-life Star Trek replicator. And listening to a list like that, well, we're right back in the realm of science fiction, aren't we? Which brings us to the single biggest question that everyone asks. How long? When does this all become our reality? And the most astonishing answer, coming directly from the researchers deep in this field, is this. They say the science is good, the engineering is feasible. So, the schedule for this revolutionary, world-changing technology? In our